Today we're going to take a look at rational expressions, and we're going to see how we can work with them, how we can simplify them. And before we get going, we're going to look at how maybe a basic fraction would be reduced. So recall that when we are multiplying fractions, all we have to do, I always think, is tops of tops, bottoms of bottoms. So you multiply the numerators with the numerators, denominators with the denominators. When we're working with fractions, we always want to try and simplify them. So for this first one, it says simplify the numerical fraction by first expressing it as a product of two fractions, one of which is equal to 1. Okay, so in other words, I could split up this 18 into two numbers. I could say that's going to be 3 times 8. I'm sorry, how about 3 times 6? That would probably be better. Okay, we got 3 times 6, and I could divide that by I could multiply 12, and I could say, well, that's going to be 2 times 6. So these two things are right now equivalent expressions. Okay, but I want to simplify this, and as you can see, each of them have a factor of 6. I would be able to reduce that 6 out, and I would be left with the answer of 3 halves. Okay, that would be the same thing as saying if I went back to this 18 over 12, and I could say 6 would divide evenly into each of these numbers. I could say 6 goes into 12 2 times. 6 divides into 18 3 times. And so again, we're left with that 3 halves. So maybe 2 different ways to look at how to reduce that fraction. Okay. Algebraically, when we get into something like this next expression, you want to think of it as factoring. I want to express it as the product of two fractions. Again, think factoring. And I'm looking at the top thinking, well, that's going to be the difference of perfect squares. So that's going to factor into x minus 3, x plus 3. And on the bottom, I can see I could pull out a common factor of 2 out of each term. And now I'm going to be left with x plus 3. Okay, so again, I can see, as it says up here, one of these fractions is going to be equal to 1. Well, if I made this, I could rewrite this and say this is x minus 3 over 2 times x plus 3 over x plus 3. Well, this x plus 3 over x plus 3, that's an equivalent fraction to 1, okay, leaving us with this as the answer. Okay. Or simply, if we just go back to how we had factored this, I can think to myself, I can reduce fractions top and bottom. Common terms can be reduced out, and so now again I'm just left with x minus 3 over 2. So just kind of depending on how you see this. Keep in mind that concept of when we are reducing things out, they reduce out to a value of 1. Okay, so every time we simplify a fraction, we're basically finding all of its common factors in the numerator and denominator and dividing them to be 1. That's the key idea here. Okay. The numerator and the denominator must be factored, and only common factors will cancel each other out. Only common factors will reduce out to a value of 1. So whether it's a monomial, a binomial, a trinomial, it doesn't matter. Every time we do this, it's the same idea. So here's some monomials and differences that we're going to see with dividing. So same thing happens when you are dividing fractions. Okay, so I'm thinking to myself, let's look at the constants first, the 3 and the 6. And a common number that goes into both 3 and 6 would be 3. 3 goes into 3 once, 3 goes into 6 twice. When we are dividing exponents, we're thinking subtract. So I'll show you 2 different ways that maybe we can handle this. So if I'm thinking subtract, that would be like saying x to the 5th minus 8. You're taking your exponents and subtracting them. And that leaves you with a negative 3. And what we know from our negative exponents is if I have a value, x to the negative 3, this is equivalent to 1 over x cubed. Okay, so if I were to start to put this answer together, I know that x cubed goes in the bottom. I always think it goes where my larger exponent happened to be. Okay, let's try it with the y's. So I have y to the 6 minus 3. When you divide exponents, you subtract, and that leaves you with y to the 3. Now 3 is positive, so what does that mean? That stays right up on the top. And notice your larger of the 2 numbers was on the top in the numerator, so it's going to stay there. Okay, we'll do the same thing for letter B. And so again, I'm going to look at the 20 and the 4, and I can say 4 goes into both of these terms evenly. 4 goes into 4 once, and 4 goes into 25 times. So if I'm thinking, let's start to write our answer, I get a 5. Okay, and now we're going to, again, subtract our exponents. And I can see my larger exponent is in my numerator, so I know what's left over will stay in the numerator. 10 minus 2, I get 8. And now I can see y to the 8th. There's only one y value, so that's going to stay y to the 8th. And that's our final answer. We could write it as that over 1, or we could just say 5x to the 8th, y to the 8th, final answer. Okay. Letter C, same idea. So a number that divides it evenly to both 7 and 21, I can find as 7. So 7 goes into 7 once. 7 goes into 21 3 times. Okay, so again, starting to write our final answer. Now I'm noticing that with both of my variables, both the x and the y, the larger of the two exponents is in the bottom. So that means when I subtract these, they're going to remain in the bottom. Okay, and again, I'll show you off on the side. I would do 3 minus 5. That would give me x to the negative 2, but I know negatives go to the bottom of the fraction. They go to the opposite side. Okay, so I try this again. Y to the 1 minus 8. And if I do 1 minus 8, I'm going to get y to the negative 7. Again, with that negative, if I want to turn that exponent positive, I have to put it to the bottom. Okay, different types of factoring. So we can simplify rational expressions that are more complicated, but again, we still have to factor first. Still identify the common factors, and then again, reduce them down to 1. So different factoring that we have going on with these. Looking at the numerator, I can factor this into 2 binomials. Okay, I'm trying to find something in this one that's going to multiply to be negative 14 and add to be 5. So I can see 7 and 2 would work. Sign of the middle term, which is positive, goes with my larger factor. So 7 times negative 2 gets me a negative 14. And if I add them, that gets me 5. Okay. On the bottom, again, here's a difference of perfect squares. So I know I'm going to have these guys, right? Square root each of your perfect squares. And then one's going to be positive, one's going to be negative. Okay, so to reduce this, I want to look and I want to see what are my common factors. Well, I see a common factor of x minus 2 in each of those. And what I have left then is an x plus 7 on top, and x plus 2 on the bottom. Final answer. Okay, we try letter B. And letter B, again, difference of perfect squares. Okay, so if I square rooted the 4 and the x squared, I would get 2x. If I square root of 1, I get 1. 1 is positive, 1 is negative. On the bottom, different factoring, I can see they each have a common factor of 5. So I pull out the 5. 5 times 2x would give me 10x. 5 times 1 would give me 5. Okay, now again, I'm going to go through and I can see these two factors are exactly the same. I can reduce them out. And so now I'm left with 2x plus 1 over 5. Okay, now we get a little bit of a harder trinomial to factor here. This one, because I have a coefficient of something other than 1, harder trinomial process, we have to find something that's going to multiply to be 24 and add to be 14. The factors that are going to work here, how about 2 and 12? Okay, everything's positive, so I don't have to worry too much about that. I'm just going to do a little bit of work on the side so we can see our factors when we're all done. So if we were to factor this, we would say copy the first, take that 14 and split it up into 2x and our 12x, and then copy the list. Okay, so then we want to do a little factor by grouping. So we're going to group these two, and we're going to group these two. And so we pull out common factors. So a common factor that I can pull out of each of these, how about is an x, and I'm going to be left with 3x plus 2. Okay, same thing now in the next one, I want to find common factors. I can pull out of each of these a 4, positive 4, and I'm going to be left with 3x plus 2 again. Okay, so to finish that factoring, We have that repeated factor of 3x plus 2, and I have the other factor of x plus 4. Okay, so that was a lot of work, but we figured out what that numerator factors out to. So I have a 3x plus 2, I have an x plus 4. Okay, the denominator, again, difference of perfect squares. So we have an x minus 4 and an x plus 4. Okay, take a look at our common factors. I can see these are our common factors. Those can get reduced out to 1. And so now in my numerator, I have 3x plus 2. In the denominator, I have x minus 4. Okay. So sometimes we get different types of factoring, all right? And we get things that look really similar like this. I see x minus y and I see y minus x. We want to see what happens to that. So first we're going to start with maybe two kind of more simple, basic ideas here. So if I did 9 minus 6 and I simplified that, that would get me 3. And if I do 6 minus 9, that's going to get me negative 3. And I know 3 divided by negative 3 simplifies down to negative 1. Okay, we'll try the next one. So 15 minus 3, I get positive 12 on the bottom. 3 minus 15, I get a negative 12. And again, if I reduce those, that's going to simplify down then to negative 1. Okay, so what happens when I do a minus b and b minus a? Well, notice what happened with each of the other two. This again is going to simplify down to negative 1. So when I see factors, they look the same, but they're in opposite orders. I have to remember, yes, these can reduce out, but they're going to reduce out to a factor of negative 1. And if we tried to see the why behind this, so why does all of this work? Well, let's see what happens here. Okay, let's say I decided to factor out a negative 1 from this top. Okay, so then what would be left? Well, a negative 1 times a negative a would give me positive a, and a negative 1 times a positive b would give me a negative b. Let's rewrite this. Keep the signs the same. This is equivalent to b minus a. And again, notice what happens. I'm still left with that negative 1. Okay, so let's try this in a couple of problems with that idea of that reducing to a negative 1. So in our numerator, I can see I could pull out a common factor of 2, and that would leave me with x minus 5. In the denominator, I have a difference of perfect squares, but notice the 25 is in front. So the square root of 25 is 5. 5 goes in front. Square root of x squared is x. X goes in the back. 1 is positive. 1 is negative. Okay, so I see this factor and this factor. They look really similar, but notice the order is different. Okay, so we just said, as long as those two things are the same, but I can see that order is opposite, these will reduce, but they reduce to a negative 1. Okay, so simplifying, I can see I'm going to have a negative 2 in my numerator, and I'm going to have a 5 plus x in my denominator. When you reduce that to a negative 1, real important, notice how I just wrote it down on my top in the numerator. It only goes to one location, so it could go to the top, or it could go to the bottom, but it cannot go to both. We'll try one more here. So I see trinomial, I have to factor it. I have to find something that's going to multiply to be 9 and add to be negative 6. So how about a negative 3 and a negative 3? Okay, on the bottom, common factors between 18 and a negative 6, I could pull out a 6. And so that would leave me with 3 minus x. Okay, so again, I'm looking at this factor and this factor, and they look really similar. It's just they are negations of each other. They're opposites. Okay, so again, I'm going to put that negative 1 in one location. It doesn't matter whether it goes to the top or the bottom. Let me show you on the bottom this time. Okay, so what do we get here? So we get a final answer. I have x minus 3 on top and a negative 6 on the bottom. Okay, what happens? Let's say I did it opposite. Let's say I went through and I actually said, well, I want the negative 1 to go on top and not on the bottom this time. Okay, so what would be the answer? Okay, so your answer could be negative x minus 3 over 6. You could also simplify that by distributing, if you wanted to, the negative through, and you would have a negative x plus 3/6. So different ways you can do it and take care of that -1. Just keep in mind it only goes to either the top or the bottom, but not both. Okay, hope you guys found this helpful. If you have questions, bring them to class. Otherwise, have a great day.